Okay, differentiation of the trigonometric function. Example 35. Given that f of x is equal to sine x, show from first principle that f1 of x, which is equal to cosine x. So in other words, given f of x is equal to sine x, we must show that the first derivative of sine x um, is equal to cosine x. All right, now from first principle, f1 of x, which is the first derivative of x, is equal to the limit as h approaches 0 of f of x plus h minus f of x, and this is over h. All right. Now, what we have to remember that f of x is equal to sine x. So f of x plus h is saying to me that in f of x, anywhere I see x, I must take out x and put x plus h. So this would be equal to sine x plus h. So therefore, f of x plus h would be equal to sine x cosine h plus cosine x sine h. So therefore, f1 of x would be equal to the limit as h approaches 0 of sine x cosine h plus cosine x sine h, which is f of x plus h, minus f of x, which is sine x, and this is all over h. All right. So bringing sine x, cosine h, and sine x together. So I'm just sort of going to rearrange some terms. So this would be equal to the limit as h approaches 0, and I'm going to have sine x cosine h minus sine x over h, plus we have what, cosine x sine h over h. All right. So all I did was I sort of like group the sine x's together, and 1 and 2, and sort of like separate the fraction into two fractions. All right. If I factor out sine x up here, I have the limit as h approaches 0, and I have sine x here, and in the other bracket I would have cosine h minus 1, and this is all over h, plus over here the limit of cosine x sine h over h, and this is the limit as h approaches 0. All right, so this would be the limit as h approaches 0 of sine x times the limit as h approaches 0 of cosine h minus 1 over h, plus the limit as h approaches 0 of cosine x multiplied by the limit as h approaches 0 of sine h over h. Alright, so if we look carefully, we can see our special limits, because the limit of cosine h minus 1 over h as h approaches 0 is equal to 0. So this limit here is going to be equal to 0, and the limit of sine h over h as h approaches 0, this limit here is equal to 1. So what we have here is sine x multiplied by 0 plus cosine x multiplied by 1, because the limit of cosine x as h approaches 0 is cosine x. Alright, and the limit of sine x as h approaches 0 is sine x, because there's no h in it. So because there's no h in it, it's not affected by h. As h changes, sine x doesn't change. As h changes, cosine x doesn't change. So this goes because it's equal to 0, and cosine x multiplied by 1 is equal to cosine x. Alright? Alright, so this was our objective. Our objective was to show that the first derivative, or the first derivative of sine x is equal to cosine x, and we have done that. Alright, in example 36, it says, given that y is equal to tan x, show that dy by dx is equal to sec square x. Alright, and this is something that we'd have to know in order to do this. We'd have to know that the first derivative of cosine x is equal to minus sine x. So a while ago we learned that if I differentiate sine x, I'm going to get what? Cosine x. Now we're also identifying that if we differentiate cosine x, we're going to get minus sine x. Alright, so here we have y is equal to tan x, and tan x is equal to sine x over cosine x. Alright, so that is a quotient, and quotient rule says that if quotient rule, can I put it in here somewhere? In essence, quotient rule says that if y is equal to u over v, where u and v are what? Are functions in x, dy by dx would be equal to v du by dx minus minus u dv by dx all over v squared. So here u is equal to sine x and v is equal to cosine x. So dy by dx would be equal to v, which is cosine x, du by dx. So remember, u is sine x and v is cosine x. So from differentiation of quotient, from the quotient rule, if you differentiate u over v, you're going to get v du by dx. So du by dx would be what happens when you differentiate sine x. When you differentiate sine x, you're going to get cosine x. So this is multiplied by cosine x minus u, which is sine x, times dv by dx, which is the differentiation of what? Cosine x. When you differentiate cosine x, you're going to get minus sine x. Alright, so it's times minus sine x all over v squared. Alright, let's remove that. All over v squared, which is cos square of x. Alright, so dy by dx is going to be equal to cos squared x plus, and we're going to have what? Sine squared x all over cosine squared x. So dy by dx would be equal to 1 over cos squared x, which is equal to sec squared x. Alright, so cos squared x plus sine squared x is equal to 1. So dy by dx would be equal to 1 over cos squared x, which is equal to sec squared x. So if we differentiate tan x, we're going to get sec squared x. Alright, given that y is equal to sec x, we're to show that dy by dx is equal to sec x tan x. Alright, so y is equal to sec x, which is the same as saying y is equal to 1 over cosine x. Alright, so let's differentiate. Let's treat it as a power derivative. So this is the same as saying y is equal to cosine x raised to the power minus 1. So let's differentiate. If we differentiate dy by dx, the power is going to come to the front. So we have minus 1 cosine x. The power decreases by 1, it becomes minus 2 times now the derivative of the inside function. The inside function is cosine x, and as we saw previously, when you differentiate cosine x, you're going to get minus sine x. Alright, so here a negative times a negative is a positive. So what we have is positive sine x cosine x to the minus 2, which is just another way of saying sine x over cos squared x. Alright, now this would be the same as saying sine x over cos x. Alright, cos squared x is equal to cos x times cos x, which is equal to sine over cos is tan. So this and 1 over cos is equal to sec. So this is the same as saying 1 over cos x times sine x over cosine x, which is equal to sec x, and sine over cos is tan x. So if we differentiate sec x, we're going to get what? Sec x tan x. Alright, so here are the standard derivative of the trig functions. These are the standard derivatives of the trig functions. So if we differentiate sine, we're going to get cosine. We saw that before. We did that from first principle. If we differentiate cosine, we get minus sine x. If we differentiate tan, we get sec squared x. If we differentiate sec x, we get sec x tan x. If we differentiate cosec x, we're going to get minus cosec x tan x. And if we differentiate cot x, we're going to get cosec squared x. Alright, let's have a look at example 38. Example 38 says find the derivative of y is equal to sine, and inside bracket we have 2x plus pi by 4. Alright, so dy by dx. First thing, chain rule, because what we have is this is a function inside of a function. This is 2x plus pi inside of sine. Inside, so it's a function in a function. And chain rule essentially says that we have to differentiate the outside function and multiply by the differential of the inside function. Now, if we differentiate sine, which is the outside function, we're going to get cos x. So this is cosine 2x plus pi by 4, multiplied now by the differential of the inside function. The inside function is 2x plus pi by 4. Pi by 4 is a constant. When we differentiate 2x plus pi by 4, we're just going to get 2. Differentiate 2x, you get 2. Differentiate pi by 4, you get 0. So dy by dx, which is the first derivative, is equal to 2 cosine 2x plus pi by 4. Alright, here we're told that y is equal to cosine 4x minus pi by 4. Chain rule again. This is a function inside of a function, and when you differentiate a function inside of a function, you must first differentiate the outside function and then multiply by the differential of the inside function. So dy by dx would be equal to, if we differentiate cos, you get minus sine, so this is minus sine, and we have 4x minus pi by 4 inside the bracket, multiply now by the differential of the inside function. The inside function is 4x minus pi by 4. If you differentiate 4x, you get 4. And if you differentiate minus pi by 4, which is a constant, you're going to get 0. So dy by dx would be equal to minus 4 sine 4x minus pi by 4. Example 40. Y is equal to sine 4x squared plus 2. Chain rule again. This is a function inside of a function. So dy by dx would be equal to differentiate sine, you get cosine 4x squared plus 2. And you differentiate the inside function, which is 4x squared plus 2. This is going to be multiplied by function. This is going to be multiplied by 2 times 4x, and the power decreases from 2 to just 1. So the answer here, dy by dx, is going to be equal to 8x cosine 4x squared plus 2.